Objective 1, function notation. This first problem is asking you to use the graph to find g of 1. So when I look for g of 1, that means when x is 1. So I see when x is 1, I can go up to this point, and that means that g of 1 is 3. So this is 3. G of negative 5. So same idea. I go across to negative 5 and down, and that points to negative 3 for g of negative 5. And then the last one, g of x is equal to 5, well, that is when y is 5. So when y is 5, I go across here and I've got two possible values. So this is at negative 7 and positive 3. So x is negative 7 or positive 3. For the second problem, we're simply substituting values in. So f of negative 10 is substituting in negative 10 for both x's. So I'll have f of negative 10 is equal to 3 times negative 10 squared plus 7 times negative 10 plus 18. The parentheses are really important, especially when you use your calculator. You should be getting a value of 248. So f of negative 10 is 248. Actually, I believe we are asking you to use the correct order of operations. So that does mean that we do need to show a little bit more work than just substituting it into our calculators. So that means that we start with the exponents. So negative 10 to the power of 2 is 100. And then we can multiply the 3 times 100 to get 300 minus 70 plus 18. And that's how we get the 248 as our final answer. Same idea with the h of 17. So h of 17 is substituting in 17 for x. So 3 times 17 minus 7 all over 5. So 3 times 17 is 51 minus 7 over 5, and that becomes 44 over 5. And I'm fine with you leaving your answer just like this. That's the final answer we're looking for. You could also write it, though, as 8.8 if you prefer decimals. For this last, the number 3, we're being asked to find when q of x is 72. So we're replacing the full left side with 72 and working our way backwards to solve for x. So we're undoing the order of operations. So I'm going to start by adding 8. And I get 80 is equal to 5 times x plus 12. Then I can divide both sides by 5. And I get, what would that be? 16 is equal to x plus 12. And I can squeeze in a minus 12. And I get x is 4. So same idea with the next one. We've got the j of x values, so that's going to be 11 is equal to the square root of x plus 5. Again, undoing order of operations, working backwards though. So I'm going to start by subtracting the 5 from both sides. And I get 6 is equal to the square root of x, and then I can undo the square root by taking the square of both sides. And I get 36. Oops. 36 is equal to x. And the last one is that function notation, the composite function. And so we're starting with the inside out. So t of negative 16 first. That's 4 times negative 16 squared plus 9. So negative 16 squared is 256. And 4 times 256 is 1024. So when we add 9, t of negative 16 is equal to 1033. Now that I know what t of negative 16 is, I can find s of that value. So we're working from the inside out. So s of negative 16 is, or not negative 16, sorry. Oops, of the 1033 is substituting it now into this equation. So that's going to be negative 1033 minus 8 all over 3. And so that would be, I have not done that one either, 1041 negative, all divided by 3. And when we divide that by 3, we do get an integer solution. So that's going to be negative 347 as our final answer. So it's the same idea with this one. We're going to start with S of 0. So S of 0 is negative 0 minus 8 over 3. So that's going to be negative 8 over 3. Or we've got fractions coming at us. That's not it, though, because now we can take that and find T of negative 8 over 3. So T of negative 8 over 3 is 4 times negative 8 over 3 squared plus 9. Now, this is messier than what you'll see on a test. I am okay on a test if you get fractions to write them as decimals, but I'm going to show you how to write it as fractions, because that is, if you're going into Algebra 2 or pre-calculus next, you're going to want to know how to do that. So when we square it, we square both sides of the fraction. We multiply just the numerators. That's 256 over 9 plus 9, but I can change 9 into, because that's the same as over 1, into ninths by multiplying by 9. So that's 81 over 9. And then I can just add the numerators, that's all over 9, and I get 337 over 9. So it is okay. This is harder than the test, so it is okay if you are struggling with this. This is to extend you into pre-calculus route.